Mr. Curran here for Curran Maths. Today we're going to be looking at all the algebraic skills you need in the 2023 National 5 Maths exam. That includes expanding brackets, factorising, completing the squares, simplifying algebraic fractions, using the four operations BIDMAS and algebraic fractions, equation of a straight line, function notation, and equations in equations, changing the subject, simultaneous equations, quadratics. So we've got 5x, 2x add 3 plus 2, 4x minus 5. Now I always imagine this like area. I'm doing 5 times the whole bracket plus 2 times the whole bracket. So you can set this up like this. If you draw yourself a box and split it in two, you can put the 5 on the outside and the 2x add 3 on the other side. Then you've got another box for the other bracket. So you've got plus 2 times 4x minus 5. Then just times everything together. So 5 times 2x is 10x. 5 times 3 is 15. 2 times 4x is 8x. 2 times negative 5 is negative 10. So putting it all together, all the x's, 10 and 8 make 18x. And then the numbers, 15 take away 10 is 5. So in total, I've got 18x add 5. Okay, this time double bracket. So we've got x add 3, x minus 5. Now you can remember a few things. You might have remembered FOIL from one of your teachers or a rainbow method. I prefer just doing a box and thinking of it like area, times and everything together. So if I draw a box, I've got 4 things because I've got 2 things on each side. 2 by 2 is 4. X add 3 on one side and then x minus 5 on the other side. Then just times everything together. X times x is x squared. X times 3 is 3x. Minus 5 times x, minus 5x, minus 5 times 3 is minus 15. Putting it all together, you've got x squared, minus 3 plus 3 minus 5 is minus 2x, and then minus 15 still on the end. Okay, another double bracket question, this time just making the numbers a bit trickier with some double negatives. Setting it up the same way, I've got 4x, take away 2 on one side, and I've got 3x, take away 6 on the other side, times and everything together. 3 times 4 is 12, so I've got 12x squared. 3 times minus 2, minus 6, so I've got minus 6x. Minus 6 times 4x, minus 24x. Minus 6 times minus 2, plus 12. Minus times a minus is a plus. Putting it together, we've got 12x squared, minus 30x in total, plus 12. Okay, double brackets again, but this time it's 3 things and 2 things. So if I make a box, I'm going to need 6 places. 3 times 2 is 6. On one side, we've got 3x squared, minus 4x, add 1. On the other side, we've got 2x, minus 5. Then we can just times everything together, being careful. 2 times 3 is 6, so I've got 6x cubed. 2 times 4 is 8, so I've got minus 8x squared. 2 times 1 is 2, of course, so plus 2x. Minus 5 times 3, minus 15x squared. Minus 5 times minus 4, watch out, plus 20x. Minus 5 times 1 is minus 5. And then we can just put it all together. But notice a little pattern here. If I just highlight this, we have got pairs here that go together. The next 2 go together. So you can simplify these 2 and then these 2. So in total, we get an answer of 6x cubed minus 23x squared, add 22x, and then take away 5. Okay, a past paper question 2019. This comes from paper 1, question 3. Quite often these questions will either come at the start of the paper, nice and easy to get you going, or maybe towards the end of the paper when you've had to write an expression yourself. But let's just deal with the simple cases. So we've got x add 5, 2x squared minus 7x take away 3. Hopefully you get an idea now. I draw my grid. On one side goes the first bracket, so I'll put x add 5 down the side, and the other side goes the other bracket. 2x squared minus 7x minus 3, times it all together. I've got x times 2x squared is 2x cubed. X times minus 7x minus 7x squared. X times minus 3 minus 3x. 5 times 2 is 10, so 10x squared. Put a plus in. 5 times 7 is 35, so minus 35x. 5 times 3 is 15, so minus 15. Putting it all together in the same way, we will have an answer of, are we ready? 2x cubed plus 3x squared minus 38x minus 15. 2017 paper 1 question 4. Very, very similar, so I'll do it the same way. Set my grid up. 2x add 3 on one side. X squared minus 4x add 1 on the other side. Times it all together. 2x cubed minus 8x squared plus 2x. And then the bottom, 3x squared minus 12x plus 3. Putting it all together, so our x squared terms becomes minus 5x squared, and our x term becomes minus 10x. So our final answer is 2x cubed minus 5x squared minus 10x and 3. Let's get right into it with some common factors. So the first question is factorise 4x squared plus 8x. This is a common factor because there's a number and letter of it going to both 4x squared and 8x, namely 4x. So 4x is what goes outside the bracket. 4x times x is 4x squared, and 4x times 2 is 8x, so it's x add 2 inside the bracket. Nice and simple, that one. Just a quick one with this. So if there's an x squared, don't assume it's double brackets. Always check first, is there a common factor? If there is, it's single bracket. If not, it will be a double bracket one. Okay, moving on. 16x squared minus 25. No common factor, so it is double brackets, and this one's called a difference of two squares. Square root of 16x squared is 4x, square root of 16 is 4, x squared is x, and the square root of 25 is of course 5. So 4x and 5 go into the brackets. So here is our answer. 4x goes in the first place, 5 goes in the last place, and you get a plus in one bracket and a minus in the other, and that is a difference of two squares. A trinomial. Trinomial means there's three things, an x squared, an x, and a number. So we're going to factorise a simple one, x squared plus 5x plus 6. So basically we're looking for two numbers that add to make 5, but times to make 6. So looking at our times in, I could have 1 times 6, obviously minus 1 times minus 6 as well. Or I could have 2 times 3, and you should be able to see, but plus 2 plus 3 makes 5. Plus 2 plus 3 is 5. 2 times 3 is 5, so that is our answer. Get our brackets. The 2 goes in one bracket, and the 3 goes in the other bracket. X in the first place. X add 2, x add 3. Nice and simple. Okay, a trinomial where there's a number in front of x squared, and always a coefficient of x squared. Start off the same way, we're looking for a sum and a product, but this time our product is the first number times the last number, 3 times 10. So that's minus 30 as our product. And our sum is still the middle number, minus 13. So starting with minus 30, just do it in order and you'll get the answer. You might be able to see it straight away. You're looking for two that make minus 30, but add or take away to make minus 13. Well, let's try minus 1 times 30. That's obviously not going to give me minus 13. Minus 2 times 15, that's the next obvious one. Oh, that's good. 15 take away 2 is 13. So or minus 15 add 2 is minus 13. So I can write that. Minus 15 add 2 is minus 13. Minus 2 times 15 is minus 30. And then we can move on to our next step, which changes slightly. It doesn't go straight into brackets. We're now going to split the middle term. So we've got 3x squared still, but instead of writing minus 13x, we're going to swap out our minus 15 add 2. So we've got minus 15x, add 2x, and then we've still got minus 10 on the end. Let's move on to our next step. So taking the 3x squared minus 15x plus 2x take away 10. If I split it down the middle, I'll just factorise each side with a common factor. So the first side, we've got to factorise 3x goes outside. 3x times x is x squared. 3x times 5 is 15, put a minus. And then when we factorise the other side, we just want to make sure that inside our bracket is the same as the first one. So it's going to start with x minus 5. I'm just going to work backwards. Something times x is 2, so it's 2. Plus 2. 2 times minus 5 is minus 10. That's us actually now done the question. Our answer is going to be what's outside the brackets, 3x add 2, and then the next one, x minus 5, is our second bracket. In other words, 3x plus 2 and x minus 5. These ones with a number in front of x squared are harder. We've got a longer process. I urge you to go through this a few times to get the hang of it. I don't want if you don't get it exact. And this is just one way to do it. Your teacher may have shown you a slightly different method, but this is one way that I feel is a good way to do it. Let's get started with completing the square. So it says express x squared plus 8x plus 19 in the form x plus p squared plus q. So we have a middle term to start with, and that goes inside the brackets, x add 4 squared. We've now got our first number. Immediately take away 4 squared. We just square that number that we've just found out. And we've still got plus 19 that goes on the end. Don't forget that. So we need to work out 4 squared and take it away from 19. So we've got x add 4 squared minus 16 add 19. Well, that gives us x add 4 squared add 3, and that's us done. If it asks us what's p and q at this stage, I would say p equals 4 and q equals 3. Example 1 says complete the square x squared plus 10x. So that's equal to x plus 5 squared. But 5 times 5 is 25, and you'll notice on the end here there is nothing. So I need to take away the extra 25 that I've just made. So the answer is x plus 5 squared, take away 25. And that is completing the square. Let's look at a second example. Example 2 says complete the square y squared minus 16y. So again, we're looking to make that look like a square bracket y, but now it's minus 8 squared because half of 16 is 8. So that will give me my 16y. But you should notice that 8 squared is 64, but there's nothing on the end. So I need to take away 64 to balance it up. So I get x minus 8, y minus 8 squared, take away 64. Let's look at an example where there is a number at the end, and also worded in a slightly different way. So example 3 says, write in the form x plus a squared plus b and state the values of a and b, m squared plus a m plus 2. Now, this is just asking you to complete the square in a different way. X plus a squared plus b is the format of completing the square, so it's just asking you to complete the square. So whenever you see x plus a squared plus b, or x plus q squared plus r, or x plus anything squared plus anything, that's just the same as asking you to complete the square. So we're just going to complete the square. So if we look at the question, it's m squared plus am plus 2. So to complete the square on that, we do m plus 4 squared, because half of 8 is 4. 4 times 4 is 16. So we're going to have to take away 16, like we did previously. But now the only extra thing here is there's the add 2. So since we've got this add 2, we have to keep the add 2 in. So we add 2. And it's really now just a check. M plus 4 squared minus 16 add 2 is minus 14. So their final answer is take away 14. And now we need to actually answer the question, state the values of a and b. So a equals 4, that's the first number, and b equals minus 14. Notice that although the question said state x plus a plus b, a or b could obviously still be negative numbers as well. So we can have a negative answer, and that's okay. All right. Okay, one final example. Example 4 says complete the square x squared minus 12x minus 3. So you should be getting the idea of the method now. We do x minus, well, half of 12 is 6. Keep the same sign. Squared. We square the 6. 6 sixes is 36, so we immediately take away what we've just squared, minus 36, but we've still got minus 3 to go. So the final answer is x minus 6 all squared. Minus 36, take away 3, just be careful, is minus 39. And there's our final answer. Nice and simple. First one says simplify 2x squared, add 2x over x squared plus 5x plus 4. Your method is always to do this. Try and factorise the top. Let's see if we can do that. Well, 2x is a common factor, so I get x add 1. Then go ahead and do the same to the bottom. So I'll try and factorise the bottom. Well, that's a trinomial, so it's double brackets. Two numbers at times to make 4, but add to make 5. Well, that's just 4 and 1. So it's x add 4, x add 1. Notice there's an x add 1 on the top, and there's an x add 1 on the bottom. We are good to go. Let's cancel these guys, and we end up with just 2x on the top and x add 4 on the bottom. No more cancellation because there's nothing exactly the same on the top and the bottom. It has to be in brackets if you're going to cancel. Simplify x squared plus 5x plus 6 over 2x squared plus 7x plus 3. More complicated, they're both trinomials, but go back to my previous videos on factorising if you need help with this. So we're factorising the top and we're going to factorise the bottom. Factorising the top would give us x add 3 and x add 2. The bottom one's really one of the more complicated ones. Have a look and see if you can do it. The answer is 2x add 1 and x add 3. You're looking for same top and bottom. So then we can cancel the x add 3's. Goodbye there, leaving us just with x add 2 and 2x add 1, and we're done. Okay, multiplying algebraic fractions. Multiplying is one of the more basic ones. Now you've got two choices. Multiply it all first, then simplify, or as I prefer to do with multiplying, simplifying in advance. So I'm looking for things on the top and bottom that are the same, or if I can simplify by cancelling down numbers. So let's start with b and b. They can go. Then we can look at 6. Divide that by 2, we get 3. Divide the 2 by 2, we get 1. We've just divided by 2. Then we can look at the 5's and the 5's, where we just cancel one another. And last thing, we've got c on the top and a c on the bottom, so they can go. So what's left? Well, on the top, we've got 3a, so 3a squared, and on the bottom, we've got just a 1. If everything's gone, it's 1. So we don't need the 1, so the answer is just 3a squared. Dividing, a little bit harder. When you divide by a fraction, always, whether it's numbers or algebra, divide turns to times, and we times by the reciprocal. What does reciprocal mean? It's like taking the fraction and turning it upside down. And it's the one after the divide sign. Let's have a look at that. Let's see how that looks. So we've got 6x squared over 7y divided by 4x over 3z. So that equals, well, we're going to have our fractions still. First of all, our divide becomes a times. Our 6x squared just goes in the place where it already was, and so does our 7y, not a problem there. But now, our 4x goes on the bottom, and our 3z goes on the top. It's turned upside down, it's a reciprocal. And now we just do the question as normal, timesing. So we can simplify in advance. So we can take an x here, dividing by x, we get x, divide the other x, it goes. And, well, I don't think there's anything, oh yes, 6 and 4. So we can divide the 6 by 2 to get 3, divide the 4 by 2 to get 2. So now just times in the top, and we get 3 times 3 is 9, xz, and times in the bottom, we get 7 times 2 is 14, y. Let's have a look, 9xz over 14y. Add-in fractions or takeaway. When you're adding, you're looking for a common denominator. Easiest way to get a common denominator with algebraic fractions, if it's just two of them, just times them together. So your common denominator is b times c, bc. And then you can think of this like a cross as a simple way to do it. Really, you're timesing the first fraction by c and the second fraction by b. So that means that you're getting 5a times c and 3d times b. Putting that together on the top then, you've got 5ac plus 3db or bd over bc. And you cannot simplify that because there's not a common thing across everything. So we're done. 2017 Specimen Paper 2 question 13, it says simplify x squared minus 4x over x squared plus x minus 20. So we factorise the top and factorise the bottom. Factorising the top, x is a common factor, so it's x minus 4, and the bottom's a trinomial, which gives you x plus 5 and x minus 4. Remember, you're looking for the same top and bottom. X minus 4, leaving just x over x plus 5. 2014, paper 2, question 9. It says express 7 over x plus 5 minus 3 over x as a single fraction. We're adding fractions. So here's our fractions. Common denominator, just times the denominators. Then we can do the first one times x and the second one times x plus 5. So putting that together, on the top we're going to get 7x minus 3 bracket x add 5 because we're timesing the whole thing by x add 5. And in the bottom, x bracket x add 5 again because it's x times x add 5. Now we can multiply out our bracket on the top. So we get 7x minus 3x minus 15 over x add 5. Simplifying the top is 4x minus 15 over x add 5. And we're done. 2015, paper 2, question 7, divide. So remember, divide changes to times, and we times by the reciprocal of the second fraction. We turn the second fraction upside down. So if we do that, look at it, we are going to get 5t over s times 2s squared over t. Now we simplify in advance. So the t's can go, we can divide by an s and to get an s on the top still. And that's it. So we've got 5 times 2 is 10, 10s. Nice, done. Okay, equation of a straight line. Let's start off with given a gradient and a point, find the equation of a straight line. So if you've got a gradient and a point, you can straight away substitute it into y equals mx plus c, or I prefer using y minus b equals mx minus a. So a reminder of how that works. M is just your gradient, and your point 3 minus 1 tells you your a and b. So a is 3 and b is minus 1. You just substitute it all in. So you get y minus 1 equals 2x minus 3. So that becomes y plus 1 is 2x minus 6 when you expand the bracket. So that gives you y equals 2x. Take away 7, taking the 1 across. Here's another example. Find the equation of a straight line with gradient 3/4 passing through minus 2, 5. So again, using y minus b equals mx minus a. Our a is minus 2, b is 5, and our gradient m is 3/4. So substituting that one in, we get y minus 5 equals 3/4 x minus 2. Now, when you've got a fraction as your gradient, it's best just to get rid of that denominator by timesing the left-hand side by the denominator, in this case 4. So we get 4 bracket y minus 5, remember your brackets, equals 3, the numerator, and then it becomes x plus 2 because x minus 2. And then we can just expand it all. 4y minus 20 on the left, 3x plus 6 on the right, and then moving it into a form that is acceptable. Or you could have preferred 4y minus 3x minus 26 equals 0. What you cannot do, this is very important, don't leave it as 4y equals 3x plus 26. That's not acceptable. The only way you can ever have it y equals is if it's only just one y, so you'd have to divide through by 4. But there's no reason to do that. National 5 Maths 2012, paper 1, question 6 said, find the equation of a line passing through minus 3, minus 1, and minus 5, 7. So our gradient formula applies where we pick x1 and y1 for our first point and x2 and y2 for our second point. Substituting that in and being careful of the signs, we get 7 take away negative 1 and minus 5 take away negative 3. So that gives me 8 over negative 2, which is negative 4. Now use the equation of a straight line, y minus b is mx minus a. So we've got our any point we want. I'll pick minus 5 for a and 7 for b. So we get y minus 7 is minus 4, x minus 5. Now be very careful of the right hand side. Inside the bracket gives us x plus 5. Plus 5 times minus 4 is negative 20. So we get y minus 7 is minus 4x take away 20. Adding 7 to both sides, we get y equals minus 4x take away 13. And we're done there. 2017, paper 1, question 6. The diagram shows a straight line passing through, joining the points A and B, find the equation. So we've given the straight line, we've got 2 points, find the gradient first, y2 minus y1 over x2 minus x1. So I'll call my first point x1, y1, and my second point x2 and y2. Substituting that in and being careful of the signs, we get minus 2 take away 6 on the top and 3 take away negative 1 on the bottom. So that gives us negative 8 over 4, which is again negative 2. Now use the equation of a straight line, y minus b equals mx minus a, where a and b is just any point you want, so pick one of the points, I'll pick 3 and minus 2 in this case. So we've got y minus minus 2 equals minus 2, x minus 3. Watch your signs. Y plus 2 is minus 2x, take away 6. Plus 6, minus 2 times minus 3 is plus 6. Watch your signs. Then taking the 2 across to the other side, you get y equals minus 2x plus 4, taking away 2 from both sides. National 5 Maths 2014, sorry, paper 1 question 8. Find the equation of a line joining these points. See a pattern here. Exactly the same again. Find the gradient. x1, y1, x2, y2. So we get 15 minus 5, 3 minus negative 2. That's 10 over 5, which is 2. Equation of a straight line. Y minus b is mx minus a. Pick a point. 3 and 15 is the most easiest one because they're both positive. So a is 3, b is 15. Y minus 15 is 2x minus 3. Expand the bracket. Y minus 15 is 2x, take away 6. Add 15 to the right hand side then, because it's negative, so it becomes positive when it moves over. Y equals 2x plus 9. 15 take away 6 is 9. 2018, paper 1 question 7, a little bit different this one. The cost of a journey with Tom's taxis depends on the distance travelled. The graph shows the cost in pounds. Point A represents 8 miles, £14. Point B is 12 miles and £20. Find the equation of a line in terms of P and D. Don't be put off by the context of this. We're giving you 2 points, so it's just the gradient, and then y minus b equals mx minus a. There's a little adjustment to be made at the end though. So here's our gradient formula. So our first point is 8 and 14. So there's my x1 and y1. And my second point was 12 and 20. So there's my x2 and y2. Substituting that in, you get 20 minus 14 on the top and 12 minus 8. So that gives me 6 over 4. Always simplify fractions. 3 over 2. So that's me got my gradient. So I can now move on and use y minus b equals mx minus a. So there's my gradient. And just pick a point, so any one you want. I'm just going to pick the 8 and the 14, or you could have picked the 12 and the 20. So there's my 8 and 14 for my A and B. So y minus 14 is 3/2 x minus 8. Watch out, we've got a fraction, so I'll times the left-hand side by 2 to give 2 bracket y minus 14 equals 3 bracket x minus 8. Multiplying out both brackets. 2y minus 28 is 3x minus 24. Moving that on further, we've got 2y is 3x plus 4 just by adding 28. And then I want y on its own this time instead of leaving it as multiples of y. So I get 3 over 2x plus 2 dividing through by 2. Why? Because I want to express my equation in terms of p and d. So this is the last bit you need to watch out for here. You need to swap the y for p and swap the x for d, because the y-axis is p and the x-axis is d. If you don't do that, you lose a mark. So you now get your final answer is p equals 3 over 2d plus 2. And there you go, that's a question in context. Part B said, let's just take it, calculate the cost of a journey of 5 miles. Well, you're going to use your formula. 5 miles, d is 5. So it's 3 over 2 times 5 plus 2. This is non-calculator. So you times by the numerator and divide by the denominator. 3 times 5 is 15. So we get 15 over 2 plus an extra 2. Now 15 divided by 2 is 7.5. Plus an extra 2 is 9.5. So it's £9.50. Watch out again. It's 9.5 is the answer, but it's money. So I need 2 decimal places. £9.50. We will come back to more questions and context later on in the course when we look at scatter graphs and the equation of a line of best fit. But for now, we'll leave that there. Let's look at the gradient and the y-intercept. A straight line has equation 3x minus 7y minus 4 equals 0. Find the gradient, the point of intersection with the y-axis and the x-axis. So you're given the equation in this case, you need to work with it. To find the gradient, you need to get it in the form y equals mx plus c. So you need to rearrange it so y is the only thing on the left-hand side. So let's start with our equation. 3x minus 7y minus 4 equals 0. So moving the x across first, we get minus 7y minus 4 is negative 3x. Moving the minus 4, that becomes positive 4 on the right. And then divide through by minus 7. Minus 3 divided by minus 7 a minus divided by a minus is a plus, you'll get 3/7 of x, and then 4 divided by -7, minus 4/7. Don't leave a minus on the bottom of your fraction. Either on the top, minus 4/7, or just at the side is fine. Now we can know our gradient, because our gradient is just a number in front of x. So our gradient is 3/7. Don't be tempted to write at the start, the gradient's 3. It's a number in front of x when it's in this form, not just a number in front of x. So when we've got our gradient, let's move on and do part B and C. Part B says the point of intersection with the y-axis. Part B, the point of intersection with the y-axis is when x equals 0. So using the original formula, 3 times 0 minus 7y minus 4 equals 0. So minus 7y take away 4 equals 0. So minus 7y equals 4. So y is minus 4/7, which is the point 0 minus 4/7. And then the point of intersection with the x-axis, that's when y equals 0. So we've got 3x, take away 7 times 0, take away 4 equals 0. That gives you 3x, take away 4, 0. So 3x equals 4. So x is 4/3, or 0, 4/3. 4/3, 0. Sorry. That's the 5 maths. 2014 paper 1 question 11 says a straight line has equation 4x plus 3y equals 12. Find the gradient of the line. Well, that's quite easy then. So we just rearrange it to make y the subject. So we've got 4x plus 3y equals 12. So taking the 4x over to the other side, we get minus 4x plus 12. Dividing through by 3, we get minus 4/3x. Plus 12 divided by 3 is 4. And then stating our gradient, m must equal minus 4/3. And we're done there. Part B says find the coordinates of a point where the line crosses the Part B says find the coordinates where a point crosses the x-axis. So we've got 4x plus 3y equals 12, remember. Cuts the x-axis when y is 0. So we've got 4x plus 3 times 0 equals 12. So 4x equals 12. So x is 12 divided by 4, which is 3. So the point is 3, 0, x and y. Okay, 2018, paper 2, question 14 says, a straight line has equation 2x minus 5y equals 12. Find the point where it crosses the y-axis. So there's our equation. Crosses the y-axis when x is 0. So we've got 2 times 0 minus 5y equals 20. So we've got minus 5y equals 20. Dividing through by minus 5. Y is minus 4. So the point is 0, minus 4. Function notation. F of x is 4x plus 2. Calculate the value of f of minus 2. Well, if we've got f of minus 2, f of minus 2 equals 4 times minus 2 plus 2. X is just minus 2. We're just substituting it in. 4 times minus 2 is minus 8. Plus 2 minus 8 add 2 is minus 6. So f of minus 2 is minus 6. So whenever you say f of a number, you just substitute a number in. Part B is the alternative. Calculate the value of a when f of a equals 22. So now the equation equals 22. So we're going to have to solve an equation. So f of a, so I'm swapping the x for an a. 4a plus 2 equals 22. Solving that, 4a equals 20. Dividing through by 4. A equals 5, and we're done there. So that's the 2 types of things you have to do with function notation. And it could be combined with surds or indices or any other thing that you already know. Let's look at some past paper questions. A function is defined as f of x equals 3x plus 2. Given f of a equals 23, find a. Well, f of a equals 3a plus 2, so that equals 23. Solving that equation, 3a must be 21. And therefore a equals 7, and we're done there. The next question says a function f of x is defined as f of x is 2 over root x. Express f of 5 as a fraction with a rational denominator. So we're coming in with surds here, but we're still the same point for part 1 for 1 mark. All you have to write is f of 5 equals 2 over root 5. And then working that out with surds, times the top and bottom by root 5 to rationalise the denominator. We get 2 root 5 on the top over 5 on the bottom, and that is as simple as it's going to get. So we're done there. National 5 Maths 2017, Paper 1, Question 1. F of x is x squared plus 3x. Calculate f of minus 5. So it's substitution. F of minus 5 equals, be careful now, it's minus 5 squared plus 3 times minus 5. Minus 5 squared is 25. Minus times a minus is a plus. 3 times minus 5 is minus 15. 25 take away 15 is 10, and we're done there. National 5 Maths 2018, Paper 2, Question 6. A function is defined as f of x is 5 plus 4x. Given f of a is 73, calculate a. So this is the one where you have to solve an equation. So we've got 5 plus 4a, because it's changed the letter, equals 73. Taking away 5 from both sides, 4a equals 73, take away 5. That gives you 68. So a is 68 divided by 4. And again, you can just calculate for this one because it is a calculator paper. But 4 goes into 6 once. 4 sevens is 28. You would get 17 as your final answer. National 5 Maths 2019, Paper 1, Question 1. F of x is 5x cubed. F of minus 2. So substituting minus 2 in, we've got 5 times minus 2 cubed. BIDMAS, remember, do the cubed bit first, then times by 5. So minus 2 cubed is 2 times 2 is 4 times 2 is 8, so it's minus 8. So it's 5 times minus 8. 5 eighths is 40, so it's negative 40 as a final answer. And finally, for functions, National 5 Maths 2022, Paper 1, Question 2, just last year. F of x is x cubed minus 2. Find f of minus 3. F of minus 3 equals minus 3 cubed, take away 2. Minus 3 cubed, well, 3 times 3 is 9, times 3 is 27. So that gives me negative 27, take away another 2, which is negative 29. Okay, solving equations. Let's look at some past papers on this. 2016, Paper 1, Question 8 said, solve this equation, give your answer in the simplest form. So we've got fractions, so we need to deal with those fractions. And the easiest way to deal with them is to get rid of them by times and by the lowest common multiple of the denominators. So if we look at the denominators here, we've got 3 and 6. The lowest common multiple between them is 6, so I times everything by 6. That's this one, and this one. So we've got 6 times 2x over 3 minus 6 times 5 over 6 equals 6 times 2x. Now we can just simplify everything as we go. So 6 divided by 3 is 2. So that gives me 2 times 2x. 6 divided by 6 is 1. So that gives me minus 5. And 6 times 2 is 12. So that gives me 12x. Now we can work out this by solving the equation. 2 2s is 4. 4x minus 5 equals 12x. Take the 4x to the other side. We get minus 5 equals 12 minus 4 is 8x. And therefore, x equals minus 5 over 8 for our final answer. National 5 Maths 2019, Paper 1, Question 14. Solve this equation. So again, the lowest common multiple between 2 and 5 is 10. So if I times everything by 10, I'll be good to go. So I've got 10 times x over 2 minus 10 times 1 equals 10 times 3 minus x over 5. Simplifying our fractions, we get 10 over 2 is 5, so that gives me 5x minus 10 equals 10 over 5 is 2. And now we can solve the equation as normal. 5x minus 10 is 6 minus 2x. Taking the x's over to the left, adding 2x gives us 7x minus 10 equals 6. So 7x equals 16. And therefore, final answer is x equals 16 over 7. Check that it's simplified. It is, so I'm done. Okay, a little bit harder this one. 2022, Paper 1, Question 15. A triangle and rectangle are shown. find an expression for the area of the triangle. So the area of a triangle is a half the base, which is 3, times the height. Don't be worried that the height is algebraic, x plus 12. So that's an expression. We can simplify that a little bit. That's 3 over 2, x plus 12. And that is a fine answer, but I'll go ahead and multiply out the brackets. We get 3 over 2, x. 12 divided by 2 is 6, times 3 is 18. So there's my area of my triangle there for our mark. And then part B says, given the area of the triangle is equal to the area of the rectangle, find the value of x. So we already know the area of a triangle is 3 over 2, x plus 18. And that equals the rectangle, this times this. So in other words, 6 times 8 minus x. If we can get that far, then we're good to go. We just need to solve our equation, okay? So let's start working on this. We've got 3 over 2x plus 18 equals 48. 8 times x is 6x. Times and through by 2, I'll write that here, 3 over 2x plus 2 times 18 equals 2 times 48 minus 2 times 6x. Make sure you times everything by 2. So that gives me 3x plus 2 times 18 is 36. 2 times 48 is 96. And 2 times 6 is 12. So we get to a simple-ish equation, moving the x's to the left-hand side. We get 15x by adding 12 plus 36 equals 96. So 15x equals 60. Dividing through by 15, we get x equals 4. Okay, linear inequalities. Let's look at some past paper questions. National 5 Maths 2017, paper 1, question 8. Solve algebraic with an inequality, and then it's shown. So these, you just treat these the same as equations, but sometimes you have to change the sign. We'll get to that in a minute if we need to. So we've got 19 plus x is greater than 15. Multiplying out the brackets, we get 3x take away 6. Now, with inequalities, it's always best just to leave your x's over. It doesn't really matter which side, but leave them positive, because if you ever get a negative x, then you have to flip the sign, which you don't want to do. So the smallest x's is on the left, so I'll move them to the right. So I've got 19 is greater than 15. 15 take away 6 is 9. So 9. 3x minus x is 2x. And then we can move the 9 over. So we get 10 is greater than 2x. So dividing through by 2, we get 5 is greater than x. And that is an acceptable answer. But a lot of times your teachers may tell you to change that so that the x is always on the left. If you wanted to do that, then you would just read it backwards. X is less than 5, so the sign changes to less than instead of greater than. But the first answer I gave you is fine as well. 2012, paper 2, question 4. So we've got 3x is less than 6 times x is 6x. 6 times 1 is 6. And then I've got to take away 12. Tidying up the right hand side, we've got 6x minus 18. Again, I'll keep all the x's positive, so I'm going to move the 18 over to the left to get minus 18 becomes 18 is less than 6x take away 3x is 3x. And then dividing through by 3, 18 divided by 3 is 6 is less than x. Or if you prefer, x is greater than 6. Now just a quick note on this, if you'd done your x's on the left, in the end you would have ended up with minus 3x on this side. When you divide by a minus, it will change that sign to the correct way around, but you don't need to remember that rule if you just remember to keep your x's positive or your unknowns. Okay, simultaneous equations. Let's start off with just solving them algebraically. So given two equations, how do we solve them? So we've got two equations here. The game and the goal is to make either the x is the same or the y is the same. Sometimes you'll have to times by one of the equations just by a number, and sometimes you'll have to times them both. In this case, I'll have to times them both. So I'm going to make the x is the same. You could make the y is the same. If I want to make the x's the same, if I times the top one by 2 and the bottom one by 3, I'll get 6 in both cases. So timesing this by 2 and timesing this by 3. So we can write our new equations, 6x plus 4y equals 34. And our bottom one is also 6x plus 15y equals 12. So I'm going to call this equation 1 and this one equation 2. And just try to keep things positive, I'll do 2 take away 1. Now, if the signs in front of the thing you're eliminating are the same, you take away. And if they're different, you would add. So these are the same, so we're going to take away. So 2 take away 1, in other words. So that gives me 15 minus 4 is 11. Y. And 12 take away 34, being very careful here. 12, 22, 32 is minus 22. Not positive 22, because remember we're doing 2 take away 1. So then dividing through by 11, y is minus 2 for our first solution. But we now need to find our second solution. So given that y is minus 2, we can just substitute that into any equation that we've already used. So I'll just use the top one, 3x plus 2y equals 17. So we know that 3x plus 2y equals 17. So we can just do 3x plus 2 times minus 2, because y is minus 2, equals 17. 3x take away 4, and then solve the equation. Add in 4, 21, 17 plus 4 is 21. So we get our final answer is x equal to 7 for our second mark. Okay, National 5 Maths 2017, paper 1, question 13 was a picture, but it gave you the 2 equations as well. It says the graph shows 2 straight lines with these equations. The lines intersect at point P. Find algebraic the coordinates of point P. If it mentions point of intersection, that means solving simultaneous equations. That's a key thing to realise. So I just need to solve both of these equations simultaneously. So if I look at my 2 equations, I've got 3x minus y and x plus 3y. So I could times one of these by 3 to make the x's the same, or times this one by 3 to make the y's the same. This time I'm going to make the y's the same. So just times in this one by 3. I can write down the new equations I get. So the first one I'm going to get is 9x minus 3y equals 6. So I can write that, 9x minus 3y equals 6. And the second equation is staying the same, x plus 3y equals 19. So I'll call that equation 1 and equation 2. And this time you can see that these numbers are the same, but they're different signs. So I add the equations when they're different signs. So I do 1 plus 2. So 9x plus 1x is 10x. The y's disappear. 19 plus 6 is 25. So x is 25 over 10. Leave that as a simplified fraction if you want, or a decimal, because it's an easy decimal. I would write 2.5 for this one. Okay, and then we need to substitute in to get our y. So just pick a simple equation. I'm just going to pick x plus 3y equals 19, because there's only one x there. So I've got 2.5 plus 3y equals 19. So 3y equals 19 minus 2 is 17, minus 0.5 is 16.5. And just checking, this was a paper 1 question, yep. So I need to divide through by 3. Three fives are 15, leaving 1. 3 5s are 15 again, 5.5. So we've now got our 2 numbers, 2.5 and 5.5, but it's to find the point, the coordinates of P. So I need to change that to a coordinate, an x and a y. So our final answer is 2.5 and 5.5. And we're done there. National 5 Maths 2018 paper 1 question 3. Solve algebraic with a system of equations. So as you see, it's the same thing over and over again. We've just to solve them by the same way, make the x's of the y's the same. So in this time, I'll make the y's the same again. So I'm going to times this one by 2 and times this one by 5. This will give me 10 for both of them. So that gives me 8x plus 10y equals minus 6. 30x minus 10y equals 25. The signs in front of the y's are different, so I can add the equations. I'll just put an add here. 38x equals 25 take away 6, which is 19. So x is 19 over 38. Always simplify your fractions. 2 19s is 38, so that's just a half. And now we substitute into any of the equations we've got to get our y. The top one, remember, was 4x plus 5y is minus 3. So x is a half, so I've got 4 times a half plus 5y equals minus 3. A half of 4 is 2, plus 5y equals minus 3. So 5y is minus 5. So y is minus 1 for our second answer. And we're done there. Moving on to solving simultaneous equations, where you have to create the equations first for the worded problem. So let's start off with 2014 paper 2, question 3. Two groups of people go to a theatre. Bill buys tickets for 5 adults and 3 children. The tickets cost £158.25. Write down an equation. 5 adults, 3 children. 5 adults plus 3 children equal 158.25. Don't put any pound signs in your equations. You might even want to write A stands for adults and C stands for children, but you don't have to. Part B is very similar. Ben buys 3 adults and 2 children tickets, and the cost is 98. Write down an equation. 3 adults plus 2 children equals 98. We've now got 2 equations we can solve. So calculate the cost of a child and adult ticket for 4 marks, simultaneous equations. Let's go. So we just write down both our equations one on top of the other. So we've got 5a plus 3c equals 158.25. And we've got 3a plus 2c equals 98. Remember, the goal is to make the a's the same or the c's the same. I'll make the c's the same. So I'm going to times the top one by 2 till we get 6, and times the bottom one by 3 to get 6. So that gives me 10a plus 6c. And this is a calculator question, you can see. So use a calculator whenever you need to. 2 times £158.25, £316, 316.5. And then 3 times 3 is 9a, 3 times 2 is 6c, and then 3 times 98, again you can use a calculator, don't be scared to use your calculator, but that's 300 minus 6, which is 294. Now, the signs are the same in front of c, so I can just take away. 10a take away 9a is 1a equals 316.5 minus 294. Again, don't be scared to use your calculator. 16.5, 22.5. Now I'll just leave that as an answer there, but we're not done yet. We need to get our c. So substituting in any equation we've already used, I'll just use the top one. 5a plus 3c was 158.25. So we've got 5a plus 3c equals £158.25. So we've got 5 times 22.5 plus 3c equals £158.25. Getting our calculator back up. 5 times 22.5 is 112.5. Plus 3c is £158.25. Taking away 112.5, so again I'll get my calculator. £158.25 minus 112.5 gives me 45.75. So 3c is 45.75, Again, I'm not going to give myself a headache. I'm going to divide that by 3. Using my calculator, divide by 15.25 divided by 3. Now, usually, when we've been doing the ones before, we'd stop there and say, we've got 2 answers, an A and a C, we've solved it. But this is a question in context. It's calculated cost of a ticket for an adult and the cost for a ticket for a child. Well, 22.5 is not a cost, and neither is 15.25 because there's no pound signs. Also, we've not really defined what A and C are, so we need to be very, very clear with our answer. So always write a little statement at the end, adult ticket equals £22.50. Child ticket equals £15.25, and we're done. If you don't like these statements, then you'll lose a mark. 14, paper 2, question 4. Moira buys 4 mangoes for the adults at a fruit shop and it costs £4.25. Write down an equation to solve this. So 4 mangoes plus 3 apples equals £4.25. Sammy buys 5 mangoes and 2 apples for £4.70. 5 mangoes plus 2 apples is £4.70. Calculate the cost of a mango and an apple. Solve them simultaneously. 4 mangoes plus 3 apples equals £4.25. 5 mangoes plus 2 apples equals £4.70. Again, this is a calculator paper, so we can use calculator anytime we want. But I'm going to make the A's the same. Times this by 2 and this one by 3 to get 6 for both A's. 2 4s is 8m plus 6a, and that gives me 8.5. 3 5s is 15m, 3 2s is 6a, and I don't want a headache on this one, so let's just do, so we can see it, 3 times £4.70, 14.1. Okay, so the signs are the same, so we're going to take away. So let's call that equation 1 and equation 2, and we're going to do 2 take away 1, just to make the m's positive. So 15 take away 8 is 7m, the a's disappear, and again, you might want to get your calculator out. 14.1 minus 8.5 is 5.6. So now we need to divide by 7. Again, you don't want to give yourself a headache. Divide your answer by 7, 0.8. And there's your m. We've worked out our m, so we need to now work out our a using any equation. You might as well just use any one you want. I'll just use 4m plus 3a is £4.25. So writing that down again, 4m plus 3a equals £4.25. m is 0.8, so I need to do 4 times 0.8 plus 3a equals £4.25. That's 3.2. Calculator if you're not sure on that one. Plus 3a equals £4.25. 3a, and just to show you, I'll use a calculator to get the answer. 4.25 minus 3.2 is 1.05. A dividing that by 3 is 0.35. Now remember, we've not actually answered the question yet. We've not said the price of a mango and the price of an apple, so we need to be very clear. Price of mango equals 2 options, £0.80 or 80 pence. Price of apple, we could say £0.35 or 35 pence would be fine as well. And we're done there. Changing the subject of the formula, let's look at linear ones first, so no squares or square roots to do, just ones where you're going to have to manipulate it as a normal standard equation almost. So the first one, 2019 paper 1 question 7 said, the area of a trapezium is given by this formula, make x the subject of the formula. So Key things with here are, if there's brackets, you need to expand them. If there's fractions, you need to get rid of them by times them by the denominator. Doesn't matter which order you do it first. I usually get rid of fractions as fast as I can. So I'm going to times both sides of this equation by 2. So in step 1, I'm going to write 2a on the left-hand side equals, well, 2 times a half is 1. So h x plus y is all that's left. And now we can expand our bracket. 2a is equal to h times x plus h times y. And we have to make x the subject, so the goal is anything with x gets left on its own. So I need to move this to the left-hand side. So I've got 2a minus hy equals hx. And I want x on its own, so I need to divide through by h. So 2a minus hy all divided by h equals x. Or you can write it the other way. X equals 2a minus hy all over h would be fine as well. 2017 paper 1 question 10 said, change the subject of the formula to b. This time was a fraction. So we need to get rid of the fraction, so I'll times both sides by c. So I can just write fc equals t squared plus 4b. And then we're ready to go. We want b on its own, so I'll take away the t squared from the left to get 4b. And I'll divide through by 4 to get fc minus t squared over 4 equals b. Or if you prefer to write it as b equals, then just switch the sides around, but keeping everything in the same order. And we're done. 2014 paper 2 question 11. So this time we have to change the subject to a, but there is a fraction. So I'm going to times everything by 2. So being very careful, but note this down. This will get times by 2, but so will this one, and then so will this one. So we end up with 2s equals 2ut plus 2 times a half is 1, so just at squared. Now we have to change the subject to a, so taking away the 2ut, because that's not got any a's in it, we get 2s minus 2ut equals at squared. And then dividing by anything attached to the a, so the t squared, we get 2s minus 2ut all over a squared equals all over t squared equals a. Or to write it round the other way, a equals 2s minus 2ut all over t squared. And we're done there. 2022, paper 1, question 7. Change the subject of the formula to b, but there's a fraction. The first thing is it's divided by c squared, so times both sides by c squared. So first step, dc squared equals b plus 4. And now we can just take away 4 to get b. So we've got dc squared minus 4 equals b, or if you prefer, b is dc squared minus 4. And that's a nice 2-mark question. Okay, changing the subjects, but when there's squares and square roots involved. So this is 2016 paper 2, question 12. Change the subject to k, but there's a square root. So I'm going to have to eliminate that square root. Well, the opposite of a square rooting is to square. So I'm just going to square both sides. So that gives me L squared. And when you square a square root, this root just disappears. So it gives me 4kt minus p, whatever's under that root. Now I can change it to k in the same way, adding p to both sides. I get L squared plus p is 4kt. Dividing through by anything which is attached to that k, which is 4 and t this time, we get L squared plus p all over 4 and t equals k. Or you can write it the other way, k equals L squared plus p over 4t. 18, paper 1, question 14. Change the subject of the formula to x. But again, we've got a root involved. Now, when it's a root, but if there's other things in the question, it's sometimes better to make the root the subject and then square at the end. It just eliminates any problems you're going to have. So I'm going to make the root x the subject. So I'm going to take away h to start with. So y minus h equals g root x. Dividing by g, we get y minus h over g equals root x. And now, since we've eliminated everything and we've got root x on its own, we can just square both sides. So we can just write a big bracket, y minus h over g squared. The whole thing's getting squared, equals x. And we're done. Identify the nature and turning point of y equals x add 2 squared minus 13. Now with this one, you can already see it's in completed square form, so the turning point is so easy. Opposite sign for the first number, same sign for the second number. In other words, turning point is negative 2, negative 13. The nature of a turning point is defined or given by the sign in front of the bracket. So, it's a positive sign in front of the bracket, that tells you that it is a minimum turning point. If it was a negative sign, it would be a maximum turning point. And there's everything you need to know for completing this square. Okay, sketching quadratics. In the 2022 National 5 exams, if you're asked to sketch a quadratic, it will be from factorised form. And you'll be asked to show the turning point, the y-intercept and the roots. Remember, roots are just where it cuts the x-axis. Let's start with the roots actually. To find the roots of a quadratic, we just make it equal to 0 and solve the equation. There'll be a later video on solving quadratics, but let's just do this one for now. So we've got 2x minus 3, x minus 10 equals 0. Nice and easy to solve. Each bracket equals 0. So we've got 2x minus 3 is 0. X minus 10 is also 0. Solve the first one, so minus 3 becomes positive 3 over 2. So it's x equals 3 over 2, and the other one, x must be 10. So we've now got our roots. Let's move to the turning point. So for the turning point, if you've got the roots, the turning point always happens in the middle of the roots. So we need to find the middle of 3 over 2 and x equals 10. There's a nice simple way to do that. Just add them up and divide by 2. So 3 over 2 plus 10 divided by 2 is what I'm going to do. That's 1.5 plus 10 over 2. That's 11.5 over 2. Get a calculator if you're unsure and you'll see that it's 5.75. Don't be put off by big numbers. If this was, I would imagine this would be a calculator question if it was going to come up for numbers like this. If it was going to be simple whole numbers, then it would be a non-calculator question. So let's move ahead and look at what happens with that number. We now need to substitute it back in to find our y value because our coordinates always got an x and a y. So we substitute into the original equation, which was 2x minus 3 and x minus 10. So I'm just x is 5.75. So I've got two 5.75s minus 3, and I've also got 5.75 minus 10. Working out each bracket, we get 8.5 times negative 4.25. Using a calculator, we get negative 36.125. So our turning point is 5.75 and negative 36.125. We've now got our turning point, so the last thing is the y-intercept. That is just happens when x equals 0, because we're not going along the x-axis, we're just going up the y. So we just substitute x equals 0 into the original equation. So there's our equation again. So it's 2 times nothing minus 3 and 0 minus 10. That gives you negative 3 times negative 10. Negative times a negative is a positive, so positive 30. As a coordinate, that gives us 0, 30. We've now got everything we need to draw a little sketch of this. Now I'm going to do it nice and neat, but in an exam, you don't have to do it as neat as this. So there's a grid, it's a curve, and putting on all the points that we've just found out, 0, 30, 10, 0, 1.5, 0, and our turning point at the bottom. In the exam, you can get away with just sketching that and putting those points in. As long as you've labelled your points fine and it doesn't look too off, you'll be complete. Mr. Clown here from Clown Maths. Today we're going to be looking at solving quadratic equations, either by factorising, already factorised, or even using the quadratic formula. Let's get straight into it with a simple example. Solve 4x squared plus 6x equals 0. So in this one, we look to see if there's a common factor first. We'll always do that. And there is a common factor. The common factor, of course, is 2x. So we can take 2x outside the bracket, and we've got 2x plus 3 inside the bracket. If you need help with factorising, look at the previous video on factorising. So then that means we've got 2x equals 0, and we've also got 2x plus 3 equals 0. So taking the first equation, x must be 0. And the second equation, well, I take the 3 over to the other side to get minus 3, then divide by the number in front of x, which is 2, so we can leave it as a fraction, minus 3 over 2, or if you prefer, minus 1.5. Okay, our second example, solve 2x add 1, x minus 2 equals 0. Notice, this is already factorised, so we don't have to do the factorising, we just need to split it into two separate equations. 2x add 1 equals 0, and also x minus 2 equals 0. Solve the first one, so we've got 2x is minus 1, and therefore x is negative a half, or minus 1 over 2. And the second one, x is equal to 2. And that's us done. Already factorised, done. It might also say, remember, find the roots of this. Same thing, finding the roots is where it cuts the x-axis. It's the same as solving a quadratic equation. So the third example I've got for you is x squared plus x minus 30 equals 0. No common factor, but it can be factorised. You'll know you're using factorisation if this turns up in the non-calculator paper and it doesn't ask you to leave your answer to one decimal place or as a root. If it just says solve it, you're factorising. Give it a go. So sum is 1 and the product is negative 30. So we're looking for numbers at times together to make 30. So we can have 1 and 30, but that doesn't make 1. 2 and 15, but that doesn't make 1. 3 and 10, but again, that doesn't make 1. Eventually we get to 5 and 6, so you might have got there quicker. And if you take 5 and 6 to get 1 as a sum, we need to do plus 6, take away 5. So that's what goes inside our brackets. And we'll just check, we've got 6 and 5 in both of them, so we're fine. So our bracket is x add 6, x take away 5 equals 0, and then we just solve it in the same way as the last question. X plus 6 equals 0, or x minus 5 equals 0. So x equals negative 6, and x equals 5. That's the last one I'm going to do on factorising. They could obviously ask you one where there's a number in front of x squared, and if you need to check how to factorise with numbers in front of x squared, go back to the factorising video, and it's the same procedure, factorise then solve. So we've got 3x squared minus x minus 2 equals 0. And I know this is a quadratic formula question. You'll know because it will say leave your answer to so many decimal places, or it's the calculator paper. So here's our quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a, where a equals 3, a number in front of x squared, b is negative 1, and c is obviously negative 2. So we just jump straight in by substituting into the formula. So that gives us, being very careful, minus 1 plus or minus the square root of minus 1 squared minus 4 times 3 times minus 2 all over 2 times 3. Now, have a look at that, make sure you're happy with that. I'm going to immediately give you the under the square root answer. You can do it all at one go in a calculator. Just use brackets. Minus 1 squared minus bracket 4 times 3 times minus 2 close bracket. And it will give you the answer. It is 25. Minus 1 squared is 1. 4 times 3 times 2 is 24. And since it's a minus times a minus, you get a plus. So it's 1 plus 24, 25. We now need to split that up into two answers. That's what the plus and minus is for. So we've got 1 plus the square root of 25 over 6 and 1 minus the square root of 25 over 6. So that's 1 plus 5 over 6 or 1 minus 5 over 6. Clearly, the first one is 6 over 6, which just gives us 1. And the second one is minus 4 over 6, which you can simplify to minus 2/3. Or if you're using your calculator and don't like a fraction, just do the top number divided by the bottom number. You'll get minus 0.666. So just write minus 0.67 to 2 decimal places, or minus 0.7 to 1 decimal place. The hardest types of questions are these questions, where you have to construct your own equation and somehow then use that equation to solve it. Often this will appear at the end of a paper, usually the calculator paper. Don't be worried if you can't do the first part of the question. Often they'll give you the equation you're going to have to use for the last part of the question. It'll be worth a number of marks. So if you can't do the first couple of parts, which I'm going to explain, skip it. and just do the last bit where you have to solve the equation. Right, let's move straight into what this is asking us. A rectangular picture measuring 9 by 13 is placed on a rectangular piece of card. And it tells us the area of the card is 270 and there's a border of x all the way around. Part A is write down an expression for the length of the card in terms of x. Part B is hence show that a quadratic equation is formed, and part C is calculate x the width of the border, giving you an answer to one decimal place. In other words, use the equation in part 2 and solve it. Let's do part A first. Here is our picture. Now we're wanting the length which is straight up the way, so if we're just looking at it going up the way, so we go up a little x, then we go up 13, and then we go up another little x again. So our length is just x plus 13 plus x. Simplifying that, it gives us 2x add 13. Quite a standard question. Let's look at part 2 then, hence solve. What does that mean? Hence show that 4x squared add 44x minus 153 equals 0. But if we look back at the question, it tells us that the area of the card is 270 square centimetres. Area. So maybe if I do the area of the card as an algebra thing, it will give me that. And that's what you should be thinking. It's talking about area. Let's write down what area is. So we know our length is 2x add 3. Let's check our breadth then. It's going to be x plus 9 plus another x, so 2x add 9. If you can get that far and you can get the 2x add 9, you're almost done. Area is length times breadth, which is equal to 270. Well, length times breadth, that's just going to be 2x add 13 times 2x add 9. Let's just expand the bracket then. 2x times 2x is 4x squared. You get 2 times 9 is 18x, 13 times 2 is 26x, plus the 117 from 9 times 13. I use a calculator for that one. And that equals 270. We're almost there. Look, we've got 4x squared. Add the x's, you get 44x. So all I need to do is take the 270 over to the left, and hopefully that'll be minus 153. And it is. So I've done it. But again, don't worry if you can't do that. If you need a little help with expanding brackets, go back to the previous video. But if you can't get that far, don't lose hope. You can still do the last part of the question because it's just solve a quadratic with the quadratic formula. The last part of the question is calculate the width of the border x, but x is in our equation. So there's our quadratic formula, just use that. We've got minus 44 plus or minus the square root of 44 squared, minus 4 times minus 153, all over 2 times 4. Notice we get minus times a minus again. Quite often you'll get that to give that positive number that comes out. If you ever get a negative answer under your square root, you have made a mistake. Go back and check. So let's work out my under square root sign, using a calculator of course. We get minus 44 plus or minus the square root of 4384. Big number, doesn't matter, we're using a calculator. Over 8, 2 times 4 is 8. Split that up into 2. Minus 44 plus root 4384 over 8, and minus 44 minus root 4384 over 8. So let's work out our answers. We get, if you do that in a calculator, 2.776, which round that to 2.8. And for the right hand side, you would get minus 13.776. Now, usually when you're solving a quadratic, you would write down both of the answers and you'll be done. But this is a real world question. This is asking you about the length of something. Have you ever seen a negative length? I haven't. So if this ever happens, you get a real world question which asks you about a length, an area, a volume, anything to do with the real world, you cannot have a negative answer. So you scroll it out. Our answer is just 2.8. And we're done. The b squared minus 4ac part is called the discriminant. So that's the discriminant part here. And we can look at the various options. We've already seen that some quadratics have no roots, some have 2 real and distinct roots, 2 real and different roots, and some quadratics have equal roots. Now, if we just examine this a minute, we're going to, in the end, square root a number. b squared minus 4ac, once you work out what that is going to give you a number. And there's 3 options. You're either going to get a positive number, and if it's positive, that means that when you square root a positive number, you get 2 answers. Square root of 25 is 5, but it's also minus 5, so there's 2 real and distinct answers. So if this bit here is positive, you get 2 real, and I'm going to use the word different roots. So that's the first possibility. if it's positive. If, on the other hand, it is 0, so the middle option, well, if you square root 0, you get 0 as well. So the square root of nothing is nothing. There's no a positive answer and a negative answer. There's just one answer, which is 0. That means I'm only going to get really one root. But we never say it's got one root. We say it's got both roots are equal. And we're using the word real again. Both roots are real and equal. So that's your second possibility. And then your third possibility is you do the sum here and you get a negative answer. So let's say if you try and square a negative number, you can't do it. Right? There's no number where you square it, the answer is negative. So if you can't square root this thing, you can't get any roots. So it's not actually got any roots. So we say it's got no real roots. So a little note on this word real. We use this word real because the set of numbers that we normally work with from minus infinity to infinity are called the real numbers. Later on in higher maths you'll learn this, we came up with a new set of numbers called the imaginary numbers, which do allow us to square root negative numbers, but we don't have to worry about that at this stage. We just use this word real because it is saying that we've got real roots or not real roots, okay? Because later on there is ways to do it with negatives, but at National 5 level, don't worry, doesn't matter. Just remember we need to use this word real when we are describing the roots, okay? Let's go into some examples. So simple example, example 1, find the nature of the roots of y equals 2x squared and 4x minus 3. So step 1 is we look for our quadratic formula. If we're doing National 5 right now, you would get that at the start of your exam paper, and we write down the bit underneath the square root sign. So your discriminant b squared minus 4ac is the bit we need. And we need to work out what our a, b and c is. So a is the number in front of x squared, so a equals 2. B is the number in front of the x, so b equals 4 in this case. And c is the final number on its own, so c equals minus 3. So I'm just going to substitute my 2, my 4, and my minus 3 into this, okay? And see what we get. So I've got 4 squared minus 4 times 2 times minus 3. That gives me 16 for the first term. Now that's a minus 4 times 2, which is minus 8. Minus 8 times minus 3. Double minus multiplied together gives you a positive. So minus 8 times minus 3 is positive 24. Add them together, 24, 40. Now the answer is not important, the number is not important. What's important is it positive, is it negative, or is it 0? This is positive, so I write a statement to say there are 2 real and different roots. B squared minus 4ac is positive. Okay, so that's example 1. Example 2 says find the nature of the roots of y equals x squared minus 6x plus 9. So like example 1, I'll find my quadratic formula and write down the discriminant, b squared minus 4ac. I'll work out my a, so that's 1, so there's nothing in front of x squared. B is negative 6, and c is 9. Substituting in here, so I've got minus 6 squared minus 4 times 1 times 9. Minus 6 squared is just 36. 4 times 1 is 4, 4 times 9 is 36, so take away 36. That gives me 0. So we know that if the discriminant is 0, there are 2 real and equal roots. So that's what I write down. 2 real equal roots, because b squared minus 4ac equals 0. That's as simple as that for example 2. Okay, Let's go on to example 3. So the last simple example, then I'll do a problem solving example. It says find the nature of the roots of y equals 2x squared minus 3x add 4. So I write down my discriminant, b squared minus 4ac. This time a equals 2, the number in front of x squared, b equals minus 3, and c equals 4. So you've got minus 3 squared minus 4 times a is 2 and c is 4. Minus 3 squared is just the number 9. 4 times 2 is 8. 8 times 4 is 32. So 9 minus 32. We should really work it out. So obviously the answer is negative, but we'll work it out. 32 take away 9 is 23, so it's minus 23. So our discriminant this time is negative. And we know that if it's negative, I can't then square root the answer, so I can't find any roots. So I write down that there are no real roots, because b squared minus 4ac is negative. And that's your 3 basic examples covered, when it's positive, when it's 0, when it's negative. And we'll do one common problem solving question as the next example. Example 4 says find the range of values of k such that kx squared minus 4x add 2 equals 0, and k, it says here, doesn't equal 0, has real roots. So I'm looking to work out for kx squared minus 4x add 2, when does that have real roots? Well, if it ever talks about real roots or the nature of the roots, we know it's a discriminant. So I look back in my page, look for the quadratic formula and find the discriminant part, b squared minus 4ac. Now usually this would have a number here, and it doesn't have a number, so it's telling me that there's a bunch of numbers that k could be, and I need to work it out. I just go through my normal steps. A would usually equal a number, but this time it's k, it's in front of x squared, b equals minus 4, and c equals 2. So I substitute that into here. So I've got minus 4 squared minus 4 times k times 2. So minus 4 squared is 16. 4 times 2 is 8, so it's minus 8k. And it says, let's go back to the question, real roots. Well, we know that if something's got real roots, it has to, the discriminant has to be positive. So this has to be greater than 0 or equal to, because it could be equal roots. So this has to be greater than or equal to 0. Nice and simple to solve. I move the 8k across. So I get 16 is greater than or equal to 8k. I divide by 8. So 2 is greater than or equal to k. And I flip the signs, because we usually write it as k, then the sign. K is less than or equal to 2. So we're just saying here the number k could be 2, 1, 0, or any other number less than 2.